Mr. Haas.
Hey, Miss Stewart.
How are you doing this morning?
Look at all those A's and B's.
I know.
Yeah.
Isn't this fun?
Yeah.
So I woke up this morning and I thought, I'm in the mood to expand some binomials.
I'm often in that mood too, but
Yeah.
first I need my orange juice.
Yes,
So,
well, I
yeah,
need my
yeah.
coffee. I had my coffee. But now it's time. So I'm just expanding. By expand, I just mean multiply out.
Oh,
So
all
a
right.
plus b to the 0, 1. That one
Sure,
didn't take
sure.
very much time.
Anything to the 0, right.
A plus b to the 1, again, that wasn't too bad. A plus b squared, well, that's just a plus b times a plus b. I did a little double distribution.
All
I
right.
got that. A plus b to the 3rd, that took a little more time. A plus b times a plus b times a plus b. I had to multiply that all together. And then I thought to myself, is there a pattern here? Is there a way I can expand these without actually doing a plus b times a plus b times a plus b times a plus b and going through it all? So I'm just looking to see if we can see any patterns here. Okay? Does that sound like fun?
That sounds good. Yeah.
All right, so
Yeah.
I started looking at the exponents. So for example, a plus b to the 4th. So if I'm looking at a to the 4th, do you see any patterns with the exponents? And people out there, why don't you pause and see if you can see any patterns that are happening with the exponents? Mr. Haas, what do you see?
Well, the exponents on the first term are in descending order. So we have-
Descending.
right.
Oh, so a to the 4th, and the 4 came from there. A to the 3rd, a squared, a to the 1th, a to the
0.
0.
Sure. Yeah.
Okay, and?
Right. And the exponents on the second term seem to be in increasing
Yeah,
order.
or ascending,
Ascending,
order.
right. I forget, what did I say? Decreasing? Increasing?
You
I
said
said
descending. Okay,
Yes,
either
let's be
one.
consistent. All right.
B to the 0, B to the 1, B to the 2, B to the 3, B to the 4.
Sure. I still
cool.
think it's increasing also works there.
I
but all
do
right.
too. All right, so I think I could figure out the exponents for my... Okay,
Yeah,
so let's
all right.
just do the exponents and then I'm going to come back to the coefficients. So this is going to be an a to the 5th, b to the 0, plus some number, a to the 4th, b to the 1, plus some coefficient, a to the 3rd, b squared. Am I doing this correctly?
Yes, looks good.
A squared, b to the 3rd, plus some number, a to the 1th, b to the 4th, plus some number, you still have me here?
I do.
B to the 5th.
Yeah.
Hey, you know, I'm seeing some other cool pattern about
So,
those.
just can I ask you a question
Yeah,
about
please.
this? So, I mean, one could just, write a plus b 5 times and just start multiplying everything out,
Yeah,
right?
yeah.
This is just a pattern that you know.
This is just a pattern
Oh,
I'm noticing
right.
so I don't have to go
right,
through all
right.
that
So this is just
rigmarole.
going to save you, but one, if you're like, what's going on? You always could.
You could always do a plus b
Right.
times a plus b times a plus b. And
I
in
see.
fact,
You just noticed that as you increase your exponents, you've looked for each little.
Thank you.
I got
Yes.
it. I got it. Okay.
yeah. Do you see another cool pattern with my exponents?
Well, I mean, if the sum of the two exponents, is that what you're looking
Yeah,
for now?
yeah.
All right.
5. 4 plus 1, 5. 3 plus 2, 5. 5, 5. That's so cool. Isn't
It
that cool?
is, yeah.
I love math. I love the patterns. Okay.
Sure. The patterns. Yeah.
So now let's think about the coefficients. I'm just going to write the coefficients over here.
Let's
Can
do
you
it.
walk this way?
Sure. Yeah.
All right.
Yeah. You want me
So-
to move way over there?
Sure,
All
why
right.
not, if that works.
This is gonna be a big move here.
Okay.
All right. Okay.
Here's a 1, and then a 1 and a 1. And then I had a 1 and a 2 and a 1. And then I had a 1 and a 3 and a 3 and a 1. And then my coefficient was 1, then 4, then 6, then 4, then 1. And again, I figured this out just by expanding
Sure.
everything out.
Okay.
Right? By actually doing a plus b times a plus b times. Okay. Then I had a 1, and ooh, we don't know what I'm going to end with. I'm pretty sure I'm going to end with a 1.
It's looking like it. Yep.
Okay, now this is interesting because the coefficients have their own pattern. Why don't we pause the video, see if you can see a pattern growing here.
You're asking the people at home.
I am,
Right,
I
okay,
am,
not
I
me.
am,
All right,
not you.
Yeah, right.
All right, Mr. Haas.
Yes.
Do you see a pattern?
Well, I mean, I happen to know the pattern.
All
have
right,
it, yeah.
lay it
So
on me.
maybe
What would
that's-
this be?
Well, that's going to be a 5.
Okay.
And that's going to be a 10,
A 10.
another 10, and a 5.
Did you have that memorized? How'd you know that? What did you do?
Well, I don't know if I saw the pattern or if I just know the pattern because, we've done this stuff before.
Okay.
But in fact, right, it's the sum of the two numbers above. Yeah.
4 plus
I agree,
6,
right.
10. 3 plus 3, 6. 2 plus 1, 3. Yeah. So you start with a 1, you end with a 1, and then you add those to get the next line. 5 plus 10, 15. 10 plus 10, 20. 10 plus 5, 15. 5 plus 1, 6. So I could keep doing this till the cows come home. This has a name. What do we often refer to this as?
This is Pascal's triangle.
Pascal's triangle. You know, it's so funny, Mr. Haas, whenever things are named after a person, so many students think, oh, he or she discovered this. Well, Pascal's triangle, this has been around for hundreds of years before Pascal was even born. But we call it Pascal's triangle. I'm not sure why. Maybe he published it or he spent time exploring
No,
it.
there's also a programming language named after Pascal.
There is. He was
Yeah.
an interesting dude.
Sure, yeah.
17th century mathematician.
Some French guy, I think.
French dude, scientist, theologian.
Sure. Yeah.
He was an interesting guy. Okay, so now, to find the coefficients for my a plus b to the 5th, I'm going to go to the row here with a 5 in it. And I know this kind of seems like smoke and mirrors, but it's a cool pattern. And these are going to be my coefficients. Will you walk with me back here?
I'm going back over there. Oh my God!
Okay,
All right, so I'm getting my exercise here. Okay.
So I'm going to put in those coefficients. So my coefficient was 1. I don't have to write that. My next coefficient should be a 5, then a 10, then a 10, then a 5, and then a 1. Isn't that cool?
That's great.
So this is basically a shortcut for expanding binomials. So can we just try one of these?
Sure, let's do it.
So what if actually, you know what? Let's just say, I'm not even going to erase much. Let's say I gave you x plus 2 to the 5th. And I wanted you to expand that. Or actually, you know what? Let's make this even easier. Let's do x plus 2.
I think you're making this up as you're going along here, Ms. Stewart. Is that what's going on now?
Let's do
Okay,
x
all right.
plus 2 to the 3rd. All right.
Now we're still with you though.
Okay.
Okay.
Let's say I want to expand out x plus 2 to the 3rd. All right.
Let's say that. Yes.
Let's say that. All right. So I am going to now, basically my a is instead going to be what?
X's.
An x.
So this also works with non-AB symbols there.
Exactly.
Okay, all right.
Isn't that
You can
brilliant?
just stick in the other ones. Oh yeah, that's great.
What's my second term?
I guess the 2 is the B there.
Yeah, so I
right,
can
okay.
replace all the b's with the 2.
All right, so far this doesn't seem too rough. Okay.
No.
All right.
All right. So now, what would x plus 2 to the 3rd be?
Well, now that you stuck a number in there, I guess we might as well
We might as well
multiply that.
simplify.
Sure,
Okay,
right.
so this is going to be 3 times x squared times 2, which is going to give me 6x squared. This is going to be 3 times x times 2 squared.
Also known as 4.
4
right?
times 3
Yeah.
plus, boom.
All right.
Now again,
Oh,
I just
okay.
want to go back. I could have, if I didn't remember all these cool patterns and shortcuts, I could have gotten that just by multiplying that out, getting my result, and doing all of that distribution. That would get me that too.
Now, I wonder, like, if you can I ask you a question about this?
Please
Okay.
do,
I
Mr.
wonder,
Huff.
like, if you have like a plus b to the 100th or something like that.
Yeah.
I'm sure there must be another way of, like, instead you don't want to have to draw like 100 rows of your Pascal's triangle. There is some other way of generating.
There
and I don't know
is.
if you want to get into that, or we
Well,
can leave that as an exercise.
Let's leave that as an exercise for people. There is absolutely another way.
Some students must be thinking about that. I
Yeah.
would guess.
There
So
absolutely
let's see if they
is.
can. Right.
Yeah, so
Okay.
think about that, and
I'm
I'll give
thinking
you.
about it. Okay.
I'll give you a hint at the
Okay.
end. So let's just do one more. What if that were a minus 2?
Ooh. Yeah.
This flummoxes some students. Okay, so I have my x as my first term, so I'm good. But now instead of a 2, really what is my second term?
I'm going to go with -2 on this, right?
So again, I'm just going to slide in little negatives. Sorry, this is a little...
Right, I'm glad you have parentheses there, boy. It's all about those parentheses.
It's all about those parentheses. Okay, so that is still going to be x to the third. What's this guy going to be now? 3 times x squared times -2. That's going to give me a negative outcome for that term. Of course, I could have said plus a negative or minus. -2 squared, positive 4 times 3, so that's still a plus 12x. -2 to the third, let's see, a negative times a negative times a negative, that's still a negative 8.
Right, so the parentheses, really sticking it into parentheses is really is what's going to get you the correct sign on these. You really have to think about the order of operations there.
Exactly.
You know, like in math, parentheses make a difference. Not like in English class, you just stick them wherever you like. In math, it really makes a difference.
It makes a difference. Okay, so I'm going to give a little hint about what you asked about. And it involves this Pascal's triangle again. And okay, so here's some more homework for people out there. Pascal's triangle is just packed with amazingness. You can find Fibonacci numbers in Pascal's triangle. You could find Sierpinski's triangle, a fractal, in this puppy. There are powers of 11. There's a whole bunch of cool, mysterious stuff. And Pascal's triangle is used not just to expand binomials, but it's used in a branch of mathematics called combinatorics, which is how to count things, probability. It's used all over the place. So I'm going to show you an example of this very quickly. Do we have another minute?
Sure.
Let's say I'm flipping a coin 3 times.
Is this the optional part of the video?
Yes.
Okay.
If I flip a coin once, what are my 2 possible outcomes?
Well, heads or tails.
Heads or tails.
Right.
Okay, so here we go.
Tails kind of coin.
Heads or tails. Let's say I flip a coin 3 times. Okay? So I'm going to say heads or tails to the third. You got me over here?
Yeah. Sorry, you're moving around a lot.
I know, I'm moving around. That's why. All right. I just saw you just in rapture with what I was saying and not looking in the camera. Okay. What are the possible outcomes if I flip a coin 3 times? Let's name some of them off.
Heads and then tails again.
Okay. Or?
Heads, heads, heads.
Or?
Tails, tails, tails.
Or
tails, tails, heads.
Yeah, okay, so
I'm thinking there's a few of them.
There are a few of them. Let's just see. Let's see. I think there is one way to get 3 heads. There are, let's see, 3 ways to get 2 heads and 1 tail. Or there are 3 ways to get 1 head and 2 tails. And there's 1 way to get 3 tails. Oh my gosh, Mr. Haas, we just expanded a binomial, but it's telling me about the outcomes of that random trial of flipping a coin 3 times.
Huh.
So that's actually a clue, perhaps, for you good thinkers out there, to figure out another way to find the number of ways.
Something to do with combinations or permutations, that kind of thing.
Yes.
And with a big exclamation point somewhere, maybe factorials in there. I don't know. I don't remember how all this stuff works.
Anyway,
but something like that.
Something. Have fun out there.
Right.
Give this a try. Thank you, Mr. Hahn.